Good afternoon, everyone. This is Raju, and in the today's class of our robotics, we would like to start with a new chapter relates to your BD2 terminology. Coming to the unit number 4, we are having your syllabus related to the dynamism of the robots. So far, we have discussed what is meant by a robot, what are the different types of robots are existing, different elements of robots are existing, what is the direction of freedom or sorry, degrees of freedom related towards the manipulator operations, different classifications of the robot based upon its coordinate systems, and two-dimensional kind of robots and three-dimensional kinds of robots. We had a detailed discussion regarding this, and the kinematics of robots, homogeneous matrices, Dinavit-Hartenberg principle, how that one link is depending upon the another link, and some of the homogeneous matrices in the case of this three-dimensional strategy when considered in the work envelope. In what way the manipulator positions will be existing upon these movements, either of the sliding movements, in the there's nothing but the prismatic kind of movements, or else the rotational kinds of movements that are taking place. We're having a detailed discussion. In the today's class, I would like to discuss the dynamics of the robot. As we have clearly observed in the case of the kinematics of a robot, we are having two subtopics, that is forward kinematics and inverse kinematics. As per our trigonometrical values has been considered in the forward kinematics, based on the coordinate frames, we have solved the problems. For example, in the coordinate one, the robot manipulator or link 1 is rotated with respect to n theta 1, and it is rotated with respect to the theta 2 by the link 2 and translated by 8 units in the case of x-axis. So this is the minimal kind of problems that we have already solved in the case of kinematics of machinery. So at this moment, after the entire transformations has been considered, transformations, nothing but rotation to link 1 and another one more rotation to the link 2 and one prismatic movement by the link 3, and within the work volume that will be saying that work envelope in the entire in its stretching mode or expanding mode, the end effector that has been surrounded by the links end link which is connected towards it, and the space that has been occupied in the working zone by this end effector is nothing but the work envelope. Hence, towards the coordinate frame, how much orientation or how much inclinations each and every link is being taking place, we had a detailed discussion. But in the dynamics of robot, we are having this Newton-Euler relations for getting clear-cut observation regarding the end effector as per the given inputs based on the programming to which area within the work envelope the space is being covered by the end effector will be updating with clear-cut global values, nothing but x, y, z coordinate systems. So three different coordinate system. In the case of this three different coordinate systems, so we'd like to have a clear cut analysis. And even this based on the environmental effects and movements of this end effectors, and with respect to different joints supporting and links supporting, will be calculating the analysis with respect to this Newton-Euler relations that we'll be seeing in detail. So what is meant by robot dynamics and how the manipulators. So manipulators in the sense nothing but a sequence of connectivity that is being existing between the n number of links. So dynamics. So what is meant by robot dynamics? Here, certain forces indeed to have a prismatic kinds of movements, that is to and fro motions, as like the cylinder and piston movements. Top dead center, moving the piston towards the top dead center and retracting back to the bottom dead centers. Nothing but that is a condition being taking place because of the applied forces. Next, certain torques. So torques in the sense about a fixed axis, one link will be getting revoluted about a fixed axis within the supporting of another link. There are the torques, and even for inclinational movements, nothing but theta movements, inclinational levels of moving the links in any of the coordinate frame. Either it may be of xy coordinate frame, yz coordinate frame, or zx coordinate frame. And secondary, we have to come to an analysis that upon moving with respect to a particular theta, the robot end effector may enter from one coordinate frame to the another coordinate frame. So this phase of actions we have clearly observed in the case of our kinematics of machinery also. So kinematics of robots also. Forward kinematics, inverse kinematics, based on the already existing position. If a further theta has been given to the particular link, it will be entering into the another coordinate system. Similarly, the phase of getting analysis or studying of these relations between these two considerations, nothing but application of the forces and observing the movements that are being taking place by its joint orientations and different links and end effector position which is existing to the wrist joint, and even resulting that particular motions clearly in the industrial manipulators for commencing of a particular task. In the industrial aspects, in the sense picking and placing of objects, and after completing the entire phenomena within the jigs and fixtures, the object need to be removed from the working environment or loading condition to unloading condition, and packing conditions should be performed over it, and heat elements should be getting removed from the work zones. These and all are the parameters that will be getting progressed in the industrial sectors. And even it is very much confined with respect to the kinematics also. For example, confiding with respect to two different models. Within the industry, we are having two different types of considerations, that is sliding actions to be performed for commencing one type of action, nothing but this stamping action. And next, torques should be applied for drying actions, by holding the objects and next rotating at a particular deviation of its orientation towards this elliptical shape or circular orientation or about a fixed axis of orientations. Clearly, in our dynamical model, it is specifying that in the input, based on the given program, in the input instructions, what are the certain forces or torques that are being implicated on the joints in order to commence the actions in the real-time basis, and observing whether those actions given in the input level is being performing by the joints and links to a particular phase of level or not. This is the clear-cut observation analysis being commenced by the dynamical motion, and hence the actions based on the given input instructions to the robot links, whether they are being satisfying as per the input levels or not, nothing but comparison activity, as we'll be calling as a control system, which acts as a basic phenomena for getting the clear-cut actions that are being done in a perfect way or not, nothing but analysis, we can say. And that analysis will be identifying very much clearly in the case of this dynamics. And these analysis will clear us indeed to have the movements of the joints for full length of operations. Coming to the inverse model of dynamics or inverse dynamic model, we can say. So while for processing the actions towards the forward movements or clockwise motions, in the case of circular interpolation towards the clockwise motions leads to some of the working progress, and sliding actions in the case of two motions, that is nothing but towards the sliding actions in positive considerations as one actions. So inverse here clears that getting back to the original position. So for example, at a 0, 0, 0 point, there is origin point, the end effector is being starting. As per the basis of its link 1, it is rotating to a 30 degrees, and link 2 is being again rotating into the 30 degrees. And finally, link 3 is a sliding. Particularly, it will be achieving and existing within the XY coordinate frame only. So after increasing or changing the values, and again need to obtain the 0, 0, 0 position, that is back to the original position, the end effector may have another trajectory. So trajectory in the sense nothing but the movement of the end effector to a particular directions. So coming to the joint accelerations, these accelerations or velocities are some of the positions that are being generated within the robot for getting a particular actions based on the designed criteria for performing the task within the industries has been satisfying or not in due analysis in the forward condition. And after completion of the task without disturbing the worked part, because if it has got any of the disturbances, dimensional accuracies will be getting deformed, will not be getting in a correct strategy. Hence, without disturbing the already existing model, the tool which is holding with respect to the end effector should get back to the horizon position without disturbing the work part. That is nothing but the inverse model, nothing but retraction model, we can say. Coming back to the origin point or the source point where it has been started initially for commencing the particular work. This is the basic phenomena need to be considered in the case of this dynamical models. Coming to the point of this dynamic model of manipulators. Basically, these manipulators are composed with open kinematic chain, and nominally the dynamic model is having the drawbacks in several concepts. First one, based on low rigidity, it will be having the high elasticity in its structure and even in its joints, as we'll be calling as those parameters such as dimensions, inertia of motion, certain mass, and the dynamic couplings among the different links, and even some of the other linear effects, normally called as these actuation systems. That and friction dead zones. You could say that friction dead zones. In any of the condition, we need to analyze the dynamical model in a mathematical condition. A series of connected rigid bodies is made, and then the analysis is being done. For studying this dynamic model. So here we are having two different kinds of problems. That is direct dynamic model and inverse dynamic model or problem. Coming to the direct dynamic model, this computation of time evolution is denoted with respect to the q double dash of t and then of qt is given the vector generalized in the case of these forces or torques that has been applied over the joints externally, in order to examine the end effector's position. And initial conditions towards this is q of t is equal to t naught and t is equal to t naught for both the conditions, that is q and q dot. Finally, we need to analyze this total time factor or time evolution as q double dash of t, q dot of t, or q of t. So upon formulating this, or upon the multiplication or the product of this q double dash of t, q dot of t, and q of t, there is nothing but the time evolutions, the total time. That is nothing but the time that has been computed with respect to the torques produced by the t by a joint and forces to a certain distance, the object that has been got slided, and finally the end effector movement has been created based upon this journey. Coming to the inverse dynamic problem, and this computation of this vector, which is necessary in order to obtain a desired trajectory in a similar strategy. Either we have been progressed in the case of this direct dynamical model, nothing but application of forces in the cases of these torques to happen that some torque conditions for revolution or rotational commencement of the links, motions of the links, and sliding motions of the links, and finally the movement of end effector need to be captured. Hence, for calculating the total time, simultaneously we will be having a product of this overall movements that are being creating within the certain joints and links with respect to the end effector movement. Commonly, we are having different reasons for studying this dynamics of a manipulator. In order to have a simulation process, which is an laboratory process, we can consider before going to the real-time basis of work. As a simulation specifies that whether the desired specifications or motions that are being acquired by the end effector upon a particular rotations or particular sliding motions that makes the actions to be confided towards the real-time basis. So in such a way, the decision making will be getting happen. So what even more in the typical kinds of situations to be added for getting the perfect output based upon some of the given inputs relates to the simulation analysis. And even that relates another method that analysis and synthesis of suitable control algorithms. So set of instructions that has been given in the form of an algorithms, nothing but in the form of a programming. And even analysis of the structural properties of the manipulator right from the design phase relates to one of the dynamical model. Why this dynamic model is being performed? Coming to our two approaches in the case of this dynamical model analysis, that is Euler Lagrange approach. So the first approach related to the Euler Lagrange approach is it's to be developed that it's very much simple in modeling, but more intuitive. It's very much understandable in nature for getting the changes, that too in the case of the mechanical parameters, nothing but proper actions need to be get commenced by the links based upon the joints. As this, all the links are considered all together and it's being modeled analytically. Even we are having some of the drawbacks here, such as even the model is obtained right from starting onwards, that is kinetic and potential energies. Hence, that particular model is not that much efficient when compared with respect to the simulation basis. It is computationally, it is not efficient. And Based upon this a computational efficient recursive technique, even there is the explicits of serial structures of industrial manipulators. We can come across that the mathematical model that is not at all expressed in a closed form. Basically, we are having two different techniques which are equivalent and providing the similar kind of results in respect to the manufacturing process or commencement of any of the actions related to the robots and its type of links. Coming to the model analysis, with the generalized variables or Lagrange coordinates as displaying with respect to the diagram, the movements will be getting charted out. And this, the independent variables, here the independent variables which are used to describe the position of these rigid bodies in the space. So in the space, that is three-dimensional. Particularly for the same system, we're having a major or more choices for the Lagrangian coordinates, which are usually possible. As such, joints will be specifying that there's the Q1 joint and this is the Q2 joint, and so on at each and every phase. This theta representation plays a major role. So confiding of the end effector position will be existing with respect to the link 2. So this is the theta 1 and this is the theta 2, and theta 1 plus theta 2 gives the original inclinational factor of this end effector with respect when it is compared with respect to the origin point. This is the joint variable analysis, and see here already the end effector is being existing with the one frame, that is normally we can say that xy plane as clearly specifying here xy plane. And if the theta has been initiated, then simultaneously the end effector is being transferring its phase from xy plane to yz plane, xy plane to yz plane. So that is depending upon this theta factor. So already it is existing with respect to in this 90 degrees or basically mutually perpendicular 120 agitations. Beyond that, theta has been prolongated at the second segment by the link number 2. Automatically, link 1 will be existing in the xy plane and link 2 will be transforming to the yz plane. Nothing but the end effector, finally the end effector position will be exactly in the second plane, that is yz plane. So the analysis that the trajectory or movement trace in order to reach the particular area in a certain directions plays a major role of getting analyzed in the case of this Euler Lagrangian formula. Nominally from physics, we have the possibilities for designing the kinematics energy and the potential K is equal to Q or Q dot energy function denoted with P of Q. Here Q refers to the link and K is the kinematic energy and P is the energy function. Therefore, the Lagrangian function, L is the Lagrangian function, L of Q comma Q dot, that is two different links, is equal to the difference of this kinematic energy function, that is the potential K of Q comma Q dot minus the energy function, that is P of Q. Hence, the Euler Lagrangian equations here are psi denoted with respect to the psi of I is equal to d by dt of double by the q dot double by the q dot of I, where I is equal to 1 comma 2, and hence based upon the different kinds of links. And psi is the external conservative of both this external or dissipative generated from the forces, generalized by the forces that leads to commencement of the work on the links, that is QI. Normally in robotics, we'll be considering torque, that is joint actuator, torque, JT, based on some of the forces, that is FC. We can say that external forces FC. And DI of QI dot frictional torque. Therefore, by considering these external forces or joint actuation torques, psi I is replaced with respect to the equation that joint actuator torque, that is Ti plus Jt of Fc, nothing but joint torque has been commenced by the external force application minus of frictional torque, which is created with respect to a driven link and a driven link, or drive gear or driven gear, driven pulley or generally. Hence, the potential energy does not depend upon the velocity. Finally, we can conclude this Euler Lagrangian equation as the following basis. Considering of xn of ki ampere of xn. In order to calculate the kinematic energy results of ZB of Vt possessed with respect to the three-dimensional axis, that is x comma y comma z, velocity or torque generated in the orientational process, or else this V proceeds towards the prismatic moments of x comma y comma z, and the frictional forces of a psi, that is dx, dy, and dz. And hence this mass has been computed by m is equal to psi of x comma y comma z dx dy and dz. Considering one of the model, Euler Lagrangian model, considering this translation of Vc and rotational velocities of the center of mass and unknown with respect to an initial frame of F naught. So considering one frame, reference frame. Hence the velocity, which is generic point, that is P, agitated within the body, that V is equal to velocity, final velocity is equal to Vc, that is towards particular translational strategy, and omega, that is rotational strategy, happened for both this P minus Pc towards the translation, and excluding this translation, only the rotation is being considered, that is Vc plus omega into R. Hence, the velocity is expressed in the frame about a fixed axis, nothing but the rigid kind of body in the sense computed, that is for a rigid body nominally is calculated. And hence, for the rotation matrix, with the application of this force, or with reference to the frames, with two different frames, that is towards the live location of the frame and comparison with respect to the base frame, auxiliary frame, and to the base frame, auxiliary frame where the working axis is that is being taking place and referred from the reference plane F naught, that is origin F naught. Hence we are having V dash is equal to V dash of C plus, that is nothing but the translational velocity plus rotational velocities, considering with respect to the R. That's the Euler model of calculations. Thank you. We'll be proceeding in the next class.